A video analyst may spend a lot of time watching videos, scrubbing through them, going backwards through them, and pausing them. It is monotonous, time-consuming work. The analyst spends time looking for events, counting them, and tries to understand them within the context of the scene, looking for spatio-temporal patterns of activity. In this video, we introduce slit-tear visualizations, which allow analysts to look for these patterns. Let's take a look at this overhead video of a pedestrian intersection. The analyst begins by specifying a pixel path of interest. We call this a slit tear. When we create a slit tear on the scene, the system generates a timeline that shows what happens under the slit tear over the course of the entire video. The timeline scrubber allows us to scrub through the video like so. In this case, we can see all the people that pass through in a 1-minute period. Drawing a slit tear like so, we can use them to see patterns of movement through the video space. In this case, each streak in the timeline represents a different individual passing through, and the direction of the streak tells us which direction they were going. One of the nice features of slit tear visualizations is that events appear as intrusions in the timeline, making them easy to spot. Suppose in this parking lot scene we are interested in how many cars pass through each of the 3 marked exits. We would draw 3 slit tears, 1 on each exit. Here we see the timelines for each slit tear composited into a single timeline, marked 1, 2, and 3 respectively, and each timeline shows all the cars passing through in a static 2D visualization. Scrubbing through the video, we can verify that each intrusion is indeed a car. In this next scene, let's take a look at an oval running track. Let's suppose you were interested in the people that passed through on the other side of the oval track, and wanted to be notified when this happened. If you draw a scribbly slit tear like this, you can actually see when this happens. The scribbly slit tear replicates pixels in the timeline, and so when events occur, they immediately draw your attention. Slit tears are also useful for seeing patterns of activity, especially those with a regular period. This slit tear reveals a double helix-like pattern for the regular stride of a walker and a jogger. Note that the jogger's relatively higher speed is revealed by the slope of her streak compared to the walker's. Our next example brings us to a car intersection. A slit tear like so allows us to see the cars as they pass through this intersection. The visualization can show you to some extent how quickly the cars are passing through the intersection as well. The more squished they appear to be horizontally, the faster they went through the intersection. Conversely, when you see a limousine, like this one here, well, that one looks that way because it's waiting to make a left turn. Now, if we draw 2 slit tears, one diagonally, we can see that the cars become slanted. This looks kind of funny, but also serves another purpose. You can now see the direction that they're slanted also shows you which direction they were moving in the video. Cars slanted backwards are cars whose wheels went through the tear first before the roof. These are moving right to left. Conversely, cars slanted forward are cars going left to right. Now the neat thing is that if you take this idea to the extreme, you can just draw a horizontal slit tear. Now you've got something that looks really neat. Again, the direction or slant of the streak tells you which way the car was going, but now you can also add a second slit tear that acts as a kind of index of the visualization too. Here's another angle on the same intersection. Nothing new here, but if we draw a slit tear across the spinning sign, it produces a nice pattern. Finally, we've already seen that it's possible to compare different parts of a video to see if they're related to each other. Here's just a webcam grab of some tough guy working an office job. We can draw a slit tear on his keyboard to see when he uses the keyboard, and another slit tear to see when he uses the mouse. You can see that the mouse cord, unsurprisingly, seems to move a lot when his hands aren't on the keyboard. And just for fun, let's draw a slit tear on the Donald Duck bobblehead doll here in the back. Here you see that the periodic action of the bobblehead doll does not have an effect on the mouse or keyboard events.